Just a word of warning in the beginning, this will be not technical talk. It will be about meaning of life, really. So if you are here to understand frameworks, JVM, CPUs, memories, it's not for you. Because this will be talk about quite different kind of computer and different kind of frameworks for computer. It's called brain. It will be a talk about frameworks for our brain, because our brain is CPU, just, you know, not binary CPU. But as every good CPU, it needs frameworks. So it's just about me. I work here at Lumes. I'm chief architect. And I'm deconstructing architecture at Lumes. Guys from my company can confirm it. We are constantly deconstructing. Not destroying, deconstructing. Because this is some kind of tradition on the presentations, I have to start with the poll. Ask questions, you'll answer, we'll get interaction between you and me. I will feel comfortable that you are not asleep. And so the first question from my side is, what are we doing every day? If you would like to explain to your mom, spouse, friend, not IT friend, what are you doing every day at work, except playing football? Solving problems. To solve the problem. Okay, imagine you don't have access to internet. What are you doing?
Without the access to the internet.
But what do you do, really? Except all of this kind of thing.
Excuse me, remember about the microphone, okay? If you would like to ask a question, just raise your hand or answer the question.
Hello, my question is it better without the microphone? We are holding it quite well.
There are rules.
Okay, writing code. Is it really what you do? Looking at the code in my previous companies, because the code in Lumes is perfect, we are not thinking. Do you think that the thing we are doing and what is expected from us is this wall of text in Eclipse or IntelliJ or Emacs or V? Is this something that your boss expects from you, customer expects for you, and this is something you really deliver, the wall of text? Does it really matter? Be interactive, because I have just 2 slides, so. What do you do, really? Writing code? You solve the problems, but at the end of the day, you solve problem too in order to make money or save money. Okay, I think it's not about code. It's about the code in production, because it doesn't matter. It's just Git SVN repository. And the only thing that really matters is this point in time when the code goes to the production. It means that it's not only code, but it's also database, network, infrastructure. This is what we really do. You deliver a system, okay? It's not the code. Code is just a side effect of building the system, okay? Okay, how you build the systems? You write the first version and release first version in the production. Then it goes back and you have a long list of features to implement and bugs to fix from maintenance. So you fix these problems. You add new features, you go back to the production, and again, you go back with the list of things to solve. You grow the software. Personally, I'm totally against the words like designing software. You design when you know what you want to deliver. Because we don't know, and for sure our boss and our product owners don't know, and even customers don't know what they want, we grow the software, okay? This is how I see software, but you grow. And because you grow, you can also use nice words like evolution. You evolve the system. You start from single line, single page, login page, and then you keep adding features and fixing. So I think we are evolving the system, okay? We start from the small cell here. You know, this is primordial soup of proteins. And the systems evolve. Why they evolve? Thank you. We do it the same to survive. So the single cell realized at some point of time that it's not able to survive alone. So this cell found a friend, and this friend found a friend, and they formed this kind of thing, but it was not perfect. It was not energy efficient. So they decided that we will specialize, and it grows. Like the same. Our system can go multiple paths. We see the one path that was chosen, but the fact is that it can grow into many directions, depending on the customers on the market. There's one interesting feature of evolution, and it's really connected to what we do. As the evolution progresses, the completeness of the system grows. It means it's more efficient. It realizes more goals. At the same time, the complexity of the system grows. We cannot fight complexity unless we decide not to grow the system. Okay? If the system doesn't grow, because complexity doesn't grow. Complexity is built in evolution. So the single cell, it was really, we can describe it in a few words. It has a core, and it has a body, and things like this. But when it comes to describing human, it's really complex. Okay? This complexity will grow no matter what. And it's the same in our case. We started with mainframes, so it was like a refrigerator, one single with multiple cores. Then we moved to thousands of servers, client-server architectures, and then we are in the clouds. We don't know how many computers we have. And to be honest, we don't know where the computer is. At least the good side of mainframe was that you knew when the computer is in the basement. For the clouds, you don't know it, and it's complex because we grow. Sometimes in evolution, there is something called, how many of you remember something from biology? Except the thing the men and women do together. In biology, you have something, evolutionary dead end. But, evolution tried. Nature tried really hard to build something that is efficient. But it stopped. We have many evolutionary dead ends in biology. It's the same in architecture. I call it crisis. We grow to the moment that we are not able to grow anymore, except CTO has enough money to pay for the grow. But we are not able to grow. At some point of time, it just stops. This is a nice picture. Sorry for the quality, but this is the best quality I can get from Google Images. How to recognize the crisis in architecture. How to recognize the evolutionary dead end. And what's the reason behind it. This is a nice picture of the iceberg. So what we see is the tip of the iceberg. Guys from Titanic also just saw the tip of the iceberg. Suddenly they realize that there's something beneath and it's bigger than the ship. We observe events. Usually we observe events. System is slow. System is not stable. Okay, who cares? Unless it becomes a pattern, okay? You have to restart. I will tell you a story. Do I have people I know? Okay. 5 years ago, 7 years ago, I worked in a company. I will tell you a story about events. And somebody from production team came to us and said, guys, we have a memory leak in our application. What to do? We're so busy. This is the event. We have a memory leak. We're so busy that we said, restart it. It was not Windows, but our own application. So guys from hosting went back and restarted the application, and never came back until we got access to production servers for something completely different, and we found that in cron tab they have a script which restarts this application every 30 minutes. It became a pattern. Okay. They didn't come back to us to find the final solution because they have a solution. They were started every 30 seconds. And that always behind the pattern is a structure of the system. There was memory leak in a database connection pool and MySQL driver, to be honest. But we just, oh, this is event. We have a problem. Fix it. Go. And this is what we do usually. Until it becomes a pattern. It becomes a problem for everyone in the company. So, back. What's the solution? Okay, to avoid such cases. I'm not IT guy. I'm a chemist. I finished chemistry. Does it matter for you? No. I will tell you why it matters, at least for me. Because I see the same problems, the same patterns, the same solutions, but with different names between chemistry and IT. And you can find it with every engineering science. But it's the same set of problems. It's the same set of sources of the problems. It's just different naming convention, if you will. So I started to think, okay, maybe there is one universal equation that will solve all of my problems. Every single problem. I will just apply this equation and say, oh, okay, works. And the truth is that there is something like this. Yeah. And it's old. It's from 18th century. So I will tell you about system thinking. And I will tell you why it's important. And we'll tell you one additional thing. I hope once you leave the room, you will buy, not my book, so I will not get money from it, a book about system thinking and stop reading this bullshit about frameworks, languages, and application servers. Because this is bullshit. Completely bullshit. What we do every day on meetings, on session, is what I called yesterday technology masturbation. Guys, sorry, but this is what it looks like. You come to the meeting, you've got the story from product owner, he reads the first line, I, as a customer, want to solve that, blah, blah, yeah? And you say, yeah, we'll do it in Groovy. No, Clojure is better. Oh, forget about Clojure, Haskell. And we are so focused on frameworks, technologies, languages, that we don't think, because they will solve our problems. And that's not true. Frameworks solve problems of the author of the framework, not yours. They were built in really specific context. The author had a problem, and he wanted to solve it. And then he thought, okay, if it's my problem, probably everyone has the same problem, so I will open source it. And this way we have Spring, Hibernate, and other frameworks. But they still solve the problem that was what was relevant at that particular point of time for this person, not for you. Okay, can I continue to bash frameworks? Yes, they free you from thinking. Yeah, I will just use Spring, Hibernate, and then when it's a problem and your boss comes to you, it doesn't work. Yeah, we have a wrong version of Spring. The code is okay, The business domain is perfect, but you know, Spring, they have really nasty problem inside. It's not my problem. Can we migrate to something different? Okay, system thinking. What it's all about? It's from the 18th century. The first idea about it, it's from UK, from United Kingdom. They have sometimes good ideas. And it's about general theory of everything. Yeah, there is. Basically, system thinking says and focuses on systems. System thinking focuses on systems. It tells you that more than is always more than the sum of its parts. Okay? So basically, this, would you buy it? Once again. Okay, maybe you're a hobbyist. I'm not. I had 2 days ago problem with, changing wheel in my bicycle, so I would not buy it. For me, this is not value. This is just piece of crap. But this one, this is definitely something, okay? So system, what is system? According to the definition from the system thinking world, is an interconnected set of elements that is coherently organized in a way that achieves something. I'll give you 10 minutes to think about it. And you will see systems everywhere. It's like when you start to do object-oriented programming, and after 2 years, you think everything is an object. Even my girlfriend is an object. Get string from object, Now I see systems everywhere, okay? And let's try to put it in our context. Interconnected set of elements. We have EJBs, which talk one to another. We have servers, application server, which talk to database. They are just interconnected components. And they are organized. Okay, this word organized is not so good. To achieve something, business goal. This is system. Organization is a system because you have interconnected elements, employees. And they are connected because they talk to each other over coffee in the morning. I'm not brave enough to teach you in this 20 minutes about systems because it's large. I will just give you terms, explain the basics, and point you to things you can read, and give you some examples to start thinking in systems. And at the end, I will show you the greatest weapon of thinking systems. System thinking is an interdisciplinary science. Usually people who are involved in it are from different worlds. It's math, it's financial, it's organization development, it's the guys from ecology, the one that hang on the tree. And because they are from different worlds and every one of them uses different language, they decided in 1950s to come to common ubiquitous language. They defined the common terms to talk about their work systems. So how they describe the systems? Basically, the core element of the system is stock. Okay? That's why I love thinking in systems, It's basically container of something, a state, okay? It can be water in container, it can be money in the bank, it can be employees in the company, lines of code in the repository, entries in the database. This is stock. Okay, but this is not system. It's just the element of the system. Where is the connection? Back. Yes, this is the connection. The flow. The second term used by system thinkers is flow. So it's the situation when you move one stock to another stock. So the water from the bottle to the glass. It can be flow of water between bottle and the glass. User stories from product backlog to iteration backlog. This is flow. And of course, flow of requests from web browser to application to database server. This is flow. Okay. So I'm going to show you the simplest possible system. Okay. This is one container, second container, and this is the flow. Okay. Interconnected. And it achieves the goal. My goal is to make this glass full. Okay. Questions? No questions. Can I continue? What happens when you have two containers is something called balancing loop. This is the situation when you have flow from one container to the other, and at the same time you have backflow from the same container to this container. So the state of the system is the same. You have the maximum capacity of the system, and it's not able to grow. Every time you add more, you have less. Every time you add more, you have less, and the opposite direction. Every time you have less, somebody adds you more. So let's back to our example. This is balancing loop. Okay, I have more here, less here. Like chemistry. But the total amount of water in the system is constant. Okay? Anyone thinking about balancing loop in life? You have constant. In IT, it's not balancing loop. I will explain in the next slide. You know, every server has its maximum capacity, 50 transactions per second. Why? Because there is balancing loop, 1,000 of balancing loops underneath the system, which keep the transaction per second from growing up. Okay? This is balancing loop. The more you add requests, the slower database is because it's busy, so it can serve less requests in the same time. You reach your 50 transactions per second. Of course, you can play with the systems. It's called parameters. You can add CPU, you can add memory. You can do many brilliant different things to change the transaction per second, but at the point of time, this is balancing loop, okay? The next interesting thing is reinforcing loop. The situation is, as you add more, the more you have. Example, these guys. The faster this guy go, the faster these guys go. So he goes faster. So they can even faster, and then you have, boom. And it's like, for example, avalanche is an example of reinforcing loop. In life, the later you come, the more your wife is pissed off. It's adding guys to the project. Yeah, we have 100 developers. They produce 100 kilo lines of code per second, but we want more, so we will add more developers. Okay, but the system becomes more complex, so we need more people to write these lines of code, and this is the myth of project managers. So we keep adding. At the same time, number of lines of code grows, but there is hidden balancing loop called complexity of the code. So at some point, it's like, okay. Any examples? Balancing, reinforcing loop, amplifier in the guitar. It's the same. Delays. This is last thing, basic thing is, it's easy. It's the time between the action and reaction. And it's the most dangerous beast everywhere. For example, if you have 3 releases a year, let me go to this example. So you write your code in January, okay? and it goes into production in June. So in June, this is the first time you realize you have a problem. But developers already forgot what's in code. This is the wrong thing. And delays, the problem with delays is that they hide the real problem. You think the problem is that the code is wrong. No, the problem is that you release every 6 months. So, what's the time? We live in a world of systems. Basically, system thinking is used in financial systems, is used in organization development, it's used in ecology. How many of you heard about limit to growth? It was a famous paper from 1977, written by some specialists, and they discovered that there is limit to growth in our population. They just created a simulation. You can find it. Just write limit to growth in Google, and they will show you diagram. They build the model of the Earth using these flows, balancing loops, and they calculated that 70 billion is maximum. Maybe the model is wrong, but at least they tried. What's interesting for us in this is traps. Do you know design patterns? You don't count. Do you know it? Yeah. Use it. Like it. Basically, system thinkers has design patterns. They call it traps. I think it's a good name for design pattern. Really, it's singleton, for example, favorite trap. But what about these traps are about common problems, common cases where systems stop to evolve and grow. So they build catalog of over 20 cases, and it's like in patterns. They have a context, they have a description of the pattern, and they have a solution, applicability of the pattern. I will tell you about, let me check, okay. I will tell you about 2 traps. One is called Tragedy of the Commons. Have you heard about it? Thank you, Tomek. Do you read anything except, tutorials? On it doesn't count on Facebook. Who had read something that is not connected to IT in the last 3 months? Yes! And you haven't heard about Tragedy of Commons? Okay, this is the beginning of system thinking. This is first article in 18th century. Basically, the story goes like this. There was a village, okay? And the village had a common, and the villagers had cows. And they had 100 of the cows on this common. And everything was beautiful and perfect. Until some nasty guy said, okay, if I add 1 more cow, I will have more milk. Oh, nobody will notice. So he added, this was a true story, he added 1 cow. After a week said, okay, nobody noticed that I added 1 cow. Let me add 10. You know where the story goes? He made money, but the grass was not able to grow so fast, so everyone else just simply lost money, lost cows. It was 1 village in the United Kingdom. Example of this in IT. Check, he's not here, okay. Some time ago, there was a system. And we had database. Imagine, we had database in the system. And we had to change the schema of the database every time, with every release. We added columns, tables, indexes, all this bullshit. And it usually took about 10 to 15 minutes to upgrade the database. Quite good. Suddenly, after one release, it took over 4 hours. We had to revert the release because there was a SLA window. And started to think. And we came to the conclusion, the most interesting conclusion, hard drives are slow. Let's add more hard drives. And let's add faster hard drives. Okay, do we have money? Yes. It was in 2000, so we still had money before the crisis. So we bought NetApp, and we used Sun storage, and it was really, great. We ran the system, the upgrade came once again, and oops, 6 hours. We have more drives, faster drives, and it takes longer. Come on, what's going on? So we decided to add even more. And then the story continues, and at some point of time, our almost bald DBA ran out of the room and say, guys, I know what's the problem. We are running backups in the same time we release the code. This is the tragedy of the commons. One process overtook resources. And this is the most common thing. We tweet parameters, okay? Here's a problem, we add memory, add CPU, will be great, good. But because we didn't look at the structure of the system, we just spent money for nothing. Of course, we had the biggest storage in the city at that time, but does it really care? Because we didn't thought about the structure of the system, we just lost money. And what is the solution? Solution proposed by the guys is called privatization. It says, of course, if you have resource that is needed for everyone, make it private. So it means, in this case, just simply, okay, release is 6 o'clock, so we'll start backup at 10. So for this time, this release will be private for the release, this resource. We didn't have to add, mommy? We didn't have to add and buy disk. We had to just think and just shift the hours, okay? So privatization is the solution for the situation when you have common resource. It's like with CPU. You don't start 10,000 processes and think, okay, they will all execute in 1 second. If the process is important, give him private time. Yeah, the next syndrome and the last one. Yeah, probably. Boiling frog syndrome. It's from biology, so it shows that system thinking is in interdisciplinary science. Do you know the story of boiling the frog? Have you boiled the frog to check it? Basically, the story goes like this, that if you put frog in a boiling water, if it's wise enough, it will escape. It will just jump. But if you put the same frog into cold water and you start to heat it slowly, it will boil itself because it will not notice. Okay? The story. Some time ago, far, far away, there was a company in Krakow. I will not name it. And they had like 20 developers, brilliant, No, Robert, not this company. They had brilliant developers, really wise, intelligent people. They wrote their own beautiful system. Nobody from the outside, India, they are just helping them. Just a small startup. And at some point of time, there were a big corporation. They came and said, oh, you're so nice, little startup, we'll buy you. And they bought this business, okay? So the developers keep just writing their code, and somebody in management said, we can make a lot of money. So they started to put customers. More and more customers. More! Give me more customers. Of course, nobody knew about it, except management and sales guys. So the guys, as you realize, they were a small company. They have like 5, 6 clients. They run into 50 clients in, one year. The guys from development started to receive more and more requests for fixes. So they started to fix. And they started to spend, in the beginning, 1 hour per week for fixes, then fighting performance problems, and then it was just whole week, and then weekends came to work on the performance problems. And the company said, oh, we don't have new features. What's going on? Oh, we have a problems, performance problems. Okay, we'll help you, and we'll hire guys from India. And this is the point where the story completely got messed up, because the guys in Poland were fighting with the performance. They didn't have time to do the knowledge transfer. So the guys from India decided to reinvent the wheel. And they started to develop their own product on the top of the existing product. So we ended up with 2 login pages. What's the moral from the story? What's the thing is that if you start a change, any type of change, if you introduce TDD, BDD, DDD, ABCD, functional programming, go functional, yo. You have to start watch your absolute metrics. Do not look at relative values, because they are so small that you then didn't notice them. They knew that the performance was slower and slower and slower and slower from time to time. But every day it was like, couple of milliseconds, that's fine. Maybe, the weather is bad and system is slower. If you do this is the recommendation from the guys from System Thinkers. If you do any kind of change, start to measure absolute values. If you introduce TDD, decide on 2, 3 metrics, because this doesn't have to work for everyone. 2 or 3 metrics and watch them. Not if they change by 2 or 3. Watch if they don't overcome certain value. Don't say, we have to be have a coverage 5% per week higher. Set the value, 80% of code coverage. Because it will save you from this kind of situations. So what's next? How about the time? My personal recommendation, just try to look for it, because there is much, much more I didn't tell you, because there are 20 this kind of traps, and there is also a long list of things called leverage points. So common solutions to common problems, and applicability of these solutions. One example, one of the leverage points is everyone loves this kind of leverage point, parameters. And by the system thinkers, it's described as a worst leverage point you can use to bring your system to a different level. Because you keep turning, okay? And when you hit the maximum and you go to CTO, give him more money. So you keep, and you doesn't change the system. You just play with the parameters. You change GC settings. You don't improve your code, making sure that it's really running as it should. You play with the GC. Then comes the new version of Java JVM, and then you have to play the game once again because the garbage collector has changed. If you would improve the code, you would not have this kind of problems, probably. Why we like parameters? Cheap. Not easy. They are cheap. You go to the production, say, 1 gigabyte more. Thank you. Of course, it's good to do it once. You have event. You have problem. It's like with iceberg. Where's my iceberg? Ooh. Come, iceberg, to me. You see the event. The system went down because out of memory. You add this memory, okay? But if the next time somebody will come to you in a week time and say, yeah, we again have a problem with memory, stop adding. start thinking. Okay. Any questions so far about it? I know I didn't show you code and frameworks, but think about yourself as a CPU with hands. And think about, it's not about only system thinking. The system thinking is not the only thing we can look at and learn from. Because, to be honest, we are quite young industry. It's like, does anyone have mom, you know the common joke, who were a programmer? Or dad, or grand? You're weird. I understand why you hate computers, you know. So we are young, and there are engineering disciplines which are older. Not necessarily everything applies from the automotive science, engineering, or from building to ourselves, but we can look, okay? Look and think, stop learning frameworks. Because my advice is simple. Kill the framework, okay? Start to use your brain. This is a list of things. They are just wikis with a catalog of patterns and solutions and leverage points and all of these discussions. And this book, just $20. And just 140 pages. Worth to try, really. The best introduction, no math, just graphs, lots of arrows, ellipses, and circles. But it will change. You will read this book as I did it, and oh, oops, yeah, I have this problem. Next page, yeah, we do it right now. So really recommend, and simply complexity, because it tells you that there is no way out. The complexity will be there, no matter if you like it or not. Thank you.